Alright, so in this problem, I have 3 to the power of x plus 9 to the power of x is equal to 27 to the power of x. So to solve this, I'm going to first start by rewriting 9 to the power of x as 3 squared to the power of x, and 27 to the power of x as 3 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can rewrite these as 3 to the power of x plus 3 to the power of x to the power of 2 is equal to 3 to the power of x to the power of 3. Now I'm going to let 3 to the power of x equal to y. So now I have y plus y squared is equal to y to the power of 3. And this cannot be written as y to the power of 3 minus y squared minus y is equal to 0. Now if I factor out y, I get y times y squared minus y minus 1 is equal to 0. So this gives me two equations. I get y equals 0 and y squared minus y minus 1 is equal to 0. So for y squared minus y minus 1 equals 0, I'm going to use the quadratic formula. And if you do end up doing it, you should get y is equal to 1 plus or minus the square root of 5 over 2. So my solutions for y are 0, 1 plus the square root of 5 over 2, and 1 minus the square root of 5 over 2. Now remember how we set 3 to the power of x equal to y. So I have 3 to the power of x is equal to 0. This is our first value of y, and you can't take the power of a number and make it equal to 0, so this is wrong. Now I have 3 to the power of x is equal to 1 minus the square root of 5 over 2, and you can't, 1 minus the square root of 5, that's going to be a negative number, and you can't take the power of a positive number and make it a negative number, so this is wrong as well. So I'm left with 3 to the power of x is equal to 1 plus the square root of 5 over 2. So to solve this, I'm going to take the log on both sides, so I have log 3 to the power of x is equal to log 1 plus the square root of 5 over 2. Now I can move this to the front, so now I have x times log 3 is equal to log 1 plus the square root of 5 over 2. And if I divide both sides by log 3, I get x is equal to log 1 plus the square root of 5 over 2 over log 3. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 3 to the power of x. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 999. Now 1 plus 1 plus 1, that's equal to 3. So now I have 3 to the power of x times 3 is equal to 999. Now I'm going to go ahead and divide both sides by 3. So then these two cancel out, and now I have 3 to the power of x is equal to 111. Now if I take the log on both sides, I have log 3 to the power of x is equal to log 111. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So for log 3 to the power of x, I can move x to the front. So now I have x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out. And now I have x is equal to log 111 over log 3. Oops, sorry, I think I made a mistake here. 999 divided by 3 is actually 333, not 111, so this is going to be log 333 over log 3. And now I'm going to rewrite log 333 as log 111 times 3 over log 3. And if I have something in the form log a times b, this is equal to log a plus log b. So log 111 times 3, that's going to equal to log 111 plus log 3 over log 3, which is the same thing as log 111 over log 3 plus log 3 over log 3, which is 1. And log 111 over log 3, that's the same thing as log base 3 of 111. So this plus 1. So this is my answer. Alright, so in this problem, I have 5 to the power of x plus 25 to the power of x is equal to 20. So to solve this, I'm going to first rewrite 25 here as 5 squared. So now I have 5 to the power of x plus 5 squared to the power of x is equal to 20. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So 5 to the power of 2 to the power of x, I can switch the places of 2 and x. So now I have 5 to the power of x plus 5 to the power of x squared is equal to 20. Now I'm going to let 5 to the power of x equal to the variable y. So now if I substitute in y for 5 to the power of x, I get y plus y squared is equal to 20. And I can rewrite this as y squared plus y is equal to 20. So now I'm going to subtract 20 on both sides. These two cancel out, and I have y squared plus y minus 20 is equal to 0. So now all we have to do is simply factor this out. Y is the same thing as 5y minus 4y. So now I'm going to factor by grouping. So first, from here, y squared plus 5y, I'm going to factor out y. So I get y times y plus 5. Minus from 4y minus 20, I'm going to factor out negative 4. So I get negative 4 times y plus 5 is equal to 0. So now if I factor out y plus 5, I get y plus 5 times y minus 4 is equal to 0. So now this is going to give me two equations. I have y plus 5 is equal to 0, and I have y minus 4 is equal to 0. So for y plus 5 equals 0, y is equal to negative 5. And for y minus 4 equals equal, y equals 4. Now remember how we let 5 to the power of x equal to y. So now this is going to give me two equations. I have 5 to the power of x is equal to negative 5, and I have 5 to the power of x is equal to 4. So first off, 5 to the power of x equals negative 5. Well, I can't take the power of a positive number and make it a negative number. So this is wrong. This equation is wrong. So now this leaves me with 5 to the power of x equals 4. So to solve this, I'm going to first take the log on both sides. So I have log 5 to the power of x is equal to log 4. This is the same thing as x times log 5 is equal to log 4. And if I divide both sides by log 5, I get x is equal to log 4 over log 5.